Our next session, how GM is driving American battery technology forward. Please welcome to the stage Kurt Kelty, Vice President, Battery, Propulsion, and Sustainability, General Motors.
Good morning. Let me wait a minute here while people get situated here. It looks like there's a little bit of movement going on. I'm Kurt. I lead up everything battery at General Motors. And I consider myself a battery guy. This is what I do. Been in the business now for over 30 years. In fact, when I joined the battery industry is when lithium-ion was first being commercialized. Back then, we were looking at the Sony camcorder and how do we get a couple minutes extra recording time in the camcorder. And now we're looking at how do we get extra miles beyond 400, even 500 miles in a single charge in vehicles. I mean, it's just incredible how far we've come over the last several decades. And I've been privileged to be a part of this. I joined Panasonic Battery back in the early 90s. And Panasonic was known as being one of, if not the leading battery cell manufacturer in the world. I went from there to Tesla. Tesla, I led the battery team there, but it was, the biggest thing I was involved in was building the world's first gigafactory, where we doubled production of battery cells around the world with one factory. From there, I went to Sila. We're developing next generation anode material, specifically a silicon carbon, which you'll see in battery cells in the next couple of years. So I brought this experience from being a material manufacturer to a cell maker to an OEM, and I brought this to GM about 1.5 years ago. And what I found here was already an incredible foundation where we've got state-of-the-art facilities, we've got deep technical expertise, and really world-class technology. So our GM vehicles are not just competitive, they're actually leading in many categories. For example, in charge rate of trucks, we have the trucks that have the fastest charge rate in the industry. We've also got the longest range vehicles in the market. The Chevy Silverado has a range of 490 miles. And just this summer, a group of engineers, they were kind of geeking out and they said, well, how far can we make this vehicle drive? So they put it under optimal conditions, they inflated the tires just right, and they drove on some of the rural streets of Michigan very slowly, and they achieved over 1,000 miles on a single charge. It's incredible what we've been able to accomplish, and we've been able to do that because we're collaborating across teams, from batteries to motors, software, and the vehicle team, all working together to really develop an exceptional vehicle. So it takes these smart teams working together to really push the boundaries of what technology can do. The Chevy Equinox, you'll notice several of our vehicles right in the entrance here. Chevy Equinox is one of them. But this is the most affordable EV that drives over 315 miles on a single charge. And we're adding to our portfolio of affordable vehicles by reintroducing the Chevy Bolt in the next couple of months. And as a teaser of that, my colleague Cassandra is going to be showing you some videos of that tomorrow in her presentation. But we do more than just trucks and affordable EVs. We also make the EV Lyric, which is what I drive. And this is a luxury EV. And this is has the #1 market share in the US among luxury EVs. And it also just recently won an award in Germany for the best luxury car of the year. It's the first time an American brand has won that award in Germany. So we're really doing well in the EV market. We're actually the #2 market share right now. We doubled our market share over the last year. In fact, our nearest competitor, we have nearly twice as much market share as they do. And our sales in August, just this last month, were the best ever for GM in EVs. So we're really doing well and progressing in the EV market. So why am I telling you this? Well, the EV market is growing. It's not growing as fast as we all want it to be, but it's growing. And foreign countries and companies are investing heavily to lead in this space. Now, at the same time, the US policy and regulatory environment is shifting. Amid all this change, GM remains focused on our mission to develop and expand upon profitable EVs. But to get there, not just as a company, but as a whole industry, we have to answer some big questions. How do we drive down the cost of EVs and batteries to make them more affordable? How do we bring the benefits of electric vehicles to more consumers? And how do we unlock the full potential of commercializing battery technology here in America so we can compete and win on a global basis? This is exactly what my team and I are doing day in and day out at GM. We're focusing on 3 goals. The first is how do we drive down the cost of our batteries? Because cost is the biggest thing that will unlock the full potential of EV sales. Second, we're improving the performance across our vehicles. And when I say performance, I'm talking about range, I'm talking about improving the fast charge capability while making sure we're maintaining the safety that's necessary. And the third thing we're focusing on is localizing the supply chain, making it independent and rooted in North America. At the heart of everything we're doing is the electrification powerhouse we're building at GM. It starts in Warren, Michigan, where we research, test, and prototype the future of battery technology. We've got auto-scale prototyping capabilities, world-class R&D facilities, and some of the best engineers in the business aligned around our zero-emission future. And it's not new. Our Kettering R&D lab is the world's first automotive research center, has long been a birthplace of EV innovation. This is where GM developed the EV1, which is the world's first mass-produced EV. It is also where we developed the Volt, the world's first mass-produced plug-in hybrid. So we have a rich history of innovation in the EV space at GM. While our electrification powerhouse spans many locations, one of the most exciting places right now is right down the road from this Kettering R&D lab. That's where we're pushing the boundaries of battery technology, pushing the boundaries, and it's home to our Wallace Battery Cell Innovation Center, which you're seeing here. At Wallace, we're prototyping full-size 200 amp-hour prismatic battery cells, the kind of scale that matters for real-world EVs. Because you have to understand, when you're developing in an R&D lab, you're developing a coin cell size battery, and you need to translate that to a full-scale size battery, which would go into a vehicle. And that's what Wallace is doing, is taking that R&D work and building full-scale cells that go into an auto. So these cells right now are in early stage prototyping, and they represent the next generation of what's possible in energy density, performance, and manufacturability. So it's not just lab work, it's auto-scale engineering, and it's happening right now. And with our new battery cell development center, which is located just behind Wallace, that's currently under construction, we'll refine and validate new cell concepts, enabling our manufacturing partners to scale up production faster and deliver high-quality cells right here in the US. GM has built one of the most advanced computational and virtual engineering capabilities in the industry. We can model changes in battery chemistry and extrapolate and see what kind of effect it'll have on the vehicle. For example, we'll use the lever of increasing or decreasing the nickel content in the chemistry. We can then see what kind of effect it has on the safety performance, or on the driving range, or on the cost of the vehicle. So we can go directly from a material that goes into our battery cells to the vehicle performance. So this used to take us months to do. Now we're down to doing this in days. So these AI tools allow us to accelerate material validation, confirm battery performance, and fast track. Let's say we want to approve a second vendor on a material. It allows us to do that much faster than we've historically been able to do it. Today, we have over 14 vehicles in our portfolio that are EVs. Oh, can you go back one? We have over 14 vehicles in our EVs. We offer the most diverse lineup of any manufacture on US roads today. Oh, go back again, sorry, I must be hitting this. Now we're building on our engineering efforts to match the ideal battery to each vehicle, optimizing the performance, cost, and range to meet the unique needs of our customers. Can you go back one? That's why we're introducing new battery cell formats to expand choices and lower costs. For example, in the future, we're going to introduce a prismatic cell form factor, and this form factor will actually reduce the part count, the number of parts in a battery pack, by nearly 50%. So form factor is one lever we have. Another lever we have is chemistry. And GM is leading here too. We're adopting flexible cell chemistries to strike the right balance between range, performance, and affordability. Our engineers are developing formulations that bridge the energy density and cost gap between the nickel-based chemistries and the iron-based chemistries, which I'll talk about shortly. That's why I'm incredibly excited about introducing our lithium manganese-rich chemistry, otherwise known as LMR, which we've developed in partnership with LG Energy Solutions. LMR unlocks the premium range and performance at a more affordable cost, making it a game-changing chemistry for especially for electric trucks and full-size SUVs. We've been working on this technology for over a decade in our labs, starting in our labs and then now scaling it at Wallace Center, which you saw earlier in the video. GM aims to be the first automaker to commercialize this LMR technology. We're going to bring it to market in early 2028. And it's a perfect example of how our battery strategy is coming to life. We're lowering costs, we're improving performance, and we're localizing the supply chain. But before we look ahead, it's important to understand how we got here and how battery chemistry has evolved over time. Many of the chemistries that power today's EVs, especially nickel-based cathodes like NMC, were only commercialized in earnest over the last decade or two. When NMC first came onto the scene, the standard mix was equal parts nickel, that's the N in NMC, M manganese, and C for cobalt. So it's equal parts of each of these three minerals. And each of these elements plays a crucial role. The cobalt, for example, it provides the thermal stability. The nickel provides the energy density. The manganese adds the structural integrity. But together, they deliver a solid, reliable performance. And at the time, it was a relatively straightforward cathode to produce in volume. But as the EV market has matured, so have our priorities. We're now focused on balancing energy density with affordability, sustainability, and supply chain resilience. And that's what's driving our next generation chemistry strategy. Over the past decade, battery engineers across the industry, including GM, have been laser focused on two things: trying to reduce cost and improve performance. And one of the fastest ways to do this has been cutting back on the most expensive material in the cathode, cobalt. So we've been taking out the cobalt and replacing it with nickel. And that shift has given rise to what we call the high nickel chemistries. And that powers the majority of EVs on the road in the US today, including all of GM's vehicles. These cathodes have offered strong performance, long range, and they've helped bring EVs to more consumers by lowering the overall cost. It's a great example of how chemistry decisions directly shape market accessibility and why GM continues to innovate in this space. With LMR, we're taking the next step forward in battery chemistry. We're building on progress made with the high nickel cathodes, but now we're pushing even further towards affordability and scalability. LMR represents what we believe is a breakthrough path for truly mass market electric trucks and full-size SUVs. We're dramatically reducing our reliance on nickel and even cobalt. And while doing that, we're increasing our use of manganese, which is abundant around the world and economical. This isn't just an incremental improvement. It's a step change towards a more cost-effective, more sustainable supply chain without compromising the performance EV drivers expect. It's the kind of innovation that makes electrification more accessible, more resilient, and more American. So where does LMR fit into our broader battery strategy? Well, we're still going to retain the high nickel. So we're going to have the high nickel that's going to be for those customers that really value the high range. We're also going to have the LFP. The LFP is appropriate for those smaller, more efficient vehicles where cost is really the main driver. But where we use LMR is right in the middle. It offers the best of both worlds, where we can get range approaching the high nickel performance, but at a cost that's similar to the LFP. And that's what makes LFP so exciting. We're not trading off affordability for range. We're delivering on both. So it's not about choosing one chemistry. We're going to have all three of these chemistries. It's about having the right chemistry for the right vehicle and building a portfolio that meets the needs of every customer. The chemistry breakthrough of using LMR also enables us to use a large prismatic form factor that I mentioned earlier. LMR in a prismatic form factor can deliver 33% more energy density than you can get in an LFP cell, but it's at a comparable cost as the LFP. So it's a breakthrough in performance, value, and manufacturability. And it's a key enabler for building affordable AVs that don't compromise on range, especially important in trucks and SUVs where energy demands are high. This new cell format is a perfect example of how GM is engineering smarter, more scalable solutions for the next generation of electric vehicles. Take the Chevy Silverado EV, which is also available. You'll see it on the entrance here. So the Silverado delivers 490 miles of range using high nickel cells. We can take that same vehicle, same battery pack, and put LFP cells in there, and we can still get 350 miles of range, which is really impressive. But we can do that and save over $6,000 in the battery pack. Now, we can also put LMR in there. And by doing this, we can get over 400 miles of range. So this is giving consumers a choice. Do you want to go for that long driving range at 490 miles, or would you rather save money and go with 400 or 350 miles? So with the LMR, we're achieving significant cost savings at the pack level compared to today's high nickel systems. So it's really a sweet spot where LMR fits in, combining meaningful range with meaningful savings, and that's what makes LMR such a powerful addition to our battery portfolio. Now, up to this point, I've talked a lot about how GM is building an electrification powerhouse. From chemistry to cell design, from prototyping to manufacturing, but that powerhouse doesn't stop at the vehicle. Batteries can do incredible things. They can power a truck. They can go 490 miles. They can back up your home during a power outage. And now they're powering AI data centers in the future of the electric grid. Earlier this summer, we announced a new collaboration with Redwood Materials to use GM second-use batteries and put them in to power data centers. So it's interesting is that last year at the same conference, I sat on the same stage with J.B. Straubel, the CEO of Redwood. And in preparing for this, there's a little ante-room over here. We were doing some discussions, and those discussions actually led to this deal being done. It just shows you the power of bringing similar thinking folks together in an environment like this, that you can make deals and really progress quickly. And that's what we did with this. So we're taking second-use batteries. So the batteries at the end of their life in an EV, instead of just sending them off to recycling, we're sending them off to a second use where they're powering an AI center. In this case, it's Redwood's 63 megawatt hour installation in Sparks, Nevada. So it's a powerful example of how GM's battery strategy is scaling beyond transportation into energy resilience, sustainability, and the digital infrastructure. So GM batteries, even in their second life, are powering data centers and microgrids. But what's even more exciting is how our EVs are starting to support the grid in real time and even have the potential to back up homes. In California, we're working with PG&E to pilot vehicle-to-grid technology. This allows energy stored in EV batteries to be sent back to the grid during peak demand, when electricity is most expensive and the grid is under the most stress. That means fewer peaker plants will need to be fired up and more clean distributed energy can be used to stabilize the grid. At the same time, EVs can also serve as an emergency generator for your home. It's really a powerful shift. EVs aren't just transportation anymore, they're becoming mobile energy assets. And this is just the beginning of how GM is helping reshape the future energy landscape. Finally, one of the biggest barriers to EV adoption isn't the vehicle itself, it's the charging infrastructure. People need to know they can charge easily, reliably, and affordably. Whether they're at home, they're at work, they're on the road, it doesn't matter. They need to have confidence in the grid and in the infrastructure. That's why we're focused on building out charging solutions that are integrated with the grid and accessible across different use cases. We're collaborating with partners like you see here, EVgo, the Flying J, Pilot, and ChargePoint to expand public charging. And we're joining forces with other automakers with Iona. It's a joint venture aimed at accelerating fast charging deployment. Today, EV drivers have access to over 250,000 chargers across North America. And we're on track to deploy over 35,000 fast charging stalls by 2030. This is a major step forward in trying to make EVs a practical choice for more people. Now, to compete globally in EVs, we need to build more than great vehicles. We need to build the industry infrastructure that supports them. That includes securing the materials, the technologies, and the manufacturing capacity behind the battery systems that power every EV we make. That's why we're moving quickly to localize our battery supply chain. We're establishing US-based manufacturing for LMR and LFP cathode materials. We're also investing in cathode precursor and active materials. By the end of the decade, we plan to localize in North America the production of separators and electrolyte. And we're working to bring production of critical minerals, including the lithium, manganese, nickel, and graphite, all closer to home. All of this adds up to a major shift. By 2028, our North American content of our battery cells will increase 8-fold. It's about building resilience, reducing dependency, and supporting domestic manufacturing at scale. So over my years in the battery industry, one thing I've learned is that battery innovation is rarely about a single breakthrough. It really is the result of steady, deliberate progress across the entire value chain. And when those pieces come together, transformation becomes possible. 30 years ago, we were building batteries for camcorders. Today, we're powering a global shift in transportation. When I first joined Panasonic in 1990, at that point, the US battery industry was already lost to Japan. But what's interesting is over the last 5 or 6 years, and something I'm really proud of, is that we're bringing this battery industry back to the US. In the last 6 years, we've invested over $125 billion in the country in EV and battery projects, over 80 of these projects. We're employing over 113,000 people across 18 states. Now, there's certainly challenges ahead of us, but there's also major opportunities for US industry. By advancing our battery technology and driving this innovation, strengthening our onshoring, and making our supply chain the most competitive in the world, we're building not just better batteries, but a stronger, more resilient US industry for the future. I'm optimistic about our prospects. We have what it takes. We have the technology, we have the manufacturing, we have the expertise. We just need to execute. Thank you.